In this lesson, we're going to be taking a look at the concept of square roots. So our goal is to understand what a square root is and how to be able to evaluate square root problems. Alright, so let's take a look at this first situation. What is the side length of a square that has an area of 25 square meters? So here's our square, 25 square meters. Now, we know that to find the area of a square, or any rectangle for that matter, it's always length times width. But in the case of a square, the side length should be the same. So we're really asking ourselves what number times itself would give us 25. Now hopefully you've come to the answer of 5. 5 meters times 5 meters would be 25 meters squared. And what we're doing here is basically the concept of square root. Just like the idea that 5 times 5, which is the same thing as 5 to the second power, is our 25, that the opposite process of taking 25 and figuring out what it was beforehand as far as the side length is what we call the square root. And we use this radical symbol to denote that. So the radical symbol with 25 is the square root of 25, which is 5. And we call it the square root because it all relates back to an actual square. And that's why, in fact, we call 5 to the second power of 5 squared. And so when we are undoing that, it's the square root. All right, so how about this problem? What is the square root of 36? In other words, what number times itself, or what number squared, would give you 36? Well, that would be 6. Now, before we move on, what a lot of people don't know is that actually there's another answer. Most of the time we don't worry about it because up until this point in our math career we haven't needed it, but really there's actually something else aside from 6 times 6, which is 36. So think about it for a moment. What number times itself would give you 36 as an answer? And again, don't forget it has to be the same number. Well, hopefully you've come up with the answer of negative 6. Negative 6 times negative 6, because the nature of multiplication and negatives becoming positive, we still get positive 36. So in fact, this problem has two answers. So now the question becomes, well, which answer is the right one, or which is the one that we're supposed to give? Well, that gets into this. If you see a problem where they're just using the radical symbol with your number, they're asking for the positive square root. In other words, what is the positive answer to the square root of 16? It's just 4. But in other cases, we actually need the other answer, the negative answer. So you'll see the negative square root. You'll see a negative symbol, a radical symbol, and then the number in question, which is 49, and that would be negative 7. And in fact, in some cases in math, we actually need both answers. So you'll start to see this symbol, positive or negative square root of 81. What that wants for us as an answer is to give the square root of 81, but both the positive 9 and negative 9. So we've got two answers here, 9 or negative 9, and you can write them out separately, or you can write it out using this positive negative symbol and put positive or negative 9. This answer and this answer equate to the same thing. Okay, so positive square roots, we give the positive answer. Negative square roots, we only give the negative answer. Both square roots, we see this positive or negative symbol, and we give both answers, either like this or like this. All right, now, what about problems where the square root is not something that comes easily to our heads? Positive or negative square root of 324. That's an awfully big number, and I don't have the square root of that committed to memory. So one strategy is prime factorization. What we can do is we can take 324 and we can make a factor tree. 324, one of its prime factors is 2, because of course it's an even number. So 2 times 162. 162 is still even, so I can take another prime factor of 2 out of that and get 81. But now 81's odd, but I happen to know that 81's divisible by 3. So 3 times 27. Running out of space here, let's go the other direction. 27 is still divisible by 3. 27 would be 3 times 9. And then of course 9 is just 3 times 3. So if I wrote this down here, I've got 324, which breaks up into 2 times 2 times 3 times 3 times 3 times 3. Now, how does that get us to the square root answer? Well, Since it's all multiplication, I'm going to take advantage of the commutative property, which says that if it's only multiplication, that multiplication can be done in any order. So in fact, what I'm going to do is I'm going to take this 2, this 3, and this 3, and group them together. Then I'm going to take the other ones, the other 2 and the other 2 3s, and group those together. Essentially what I've done is I've broken up the 6 different factors into 2 of the same grouping, 2, 3, 3, 2, 3, 3. Now if I put those back together, 2 times 3 times 3, that's 18. So I find out that 324 is really just 18 times 18 in disguise. So now I've got my answer. I can go back up here and say, okay, the answer is positive or negative 18. Now, what about another strategy? How about this problem? The negative square root of 289. Let's try a different strategy using targeted estimation. Now, by targeted estimation, meaning that let's just not take a guess, let's actually think about it a little bit. For example, if we temporarily ignore the negative, I happen to know that the square root of 100 is 10. That's an easy one. The square root of 400, I happen to know, happens to be 20 times 20. And so again, temporarily ignoring the negative, 289 is somewhere in between those two. So I know my answer is somewhere in the teens. Now I can also see that 289 is a bit closer to 400 than it is 100, so as far as my guess, I'm thinking maybe 16. So what I do is on some scratch paper, I try 16 times 16. 6 times 6 is 36, carry the 3, that's going to be 9. Now, right away I know this is not the right answer because this is going to end in 6, but my number ends in 9. But I'm still going to keep going, 1 times 16, because even though this is not the right answer, it's going to give me a good idea of where to adjust my guess. Should I adjust towards a higher number or a lower number? So 256 happens to be just a little bit below 289, which means I want to take my next estimate and go a little bit higher. Again, using targeted estimation. So 17 times 17. 7 times 7 is 49, carry the 4. That's going to be 11. 1 times 17, that's 17. Add them up. And sure enough, I get 289. So 17 times 17 is 289. So over here, the negative square root of 289 is negative 17. So two strategies anytime the number is a little bit tough to figure out. Either targeted estimates like we did here, or prime factorization like in the last slide.